Good morning, students. And once again, I welcome you all for the online teaching learning session for General Science. Dear students, I hope you all are enjoying the online sessions of all the subjects. We were very happy, all the teachers were very happy to see your beautiful smiling faces in the online sessions, and we are going to continue with that. Dear students, in the last lecture we had finished with the workbook exercise of lesson number 4, and I am pretty sure that you all have simultaneously completed the workbooks. Students, please keep completing your books time to time so that the work doesn't pile up. And as I had told you that practice and learn and try out all those questions, you have to find out the answers on your own. You can write the answers in short, okay? And the workbook exercise is already discussed by me. Now today we are going to start with lesson number 5, inside the atom. So let's start with the atom. Molecules. And molecules in term are made up of atoms, right? So that means atom is the smallest unit of matter. It cannot be further broken down into still smaller units. It is the smallest unit, right? And it retains the chemical identity, that is, the atom has the chemical and physical properties of the matter, right? So, how the molecules are formed from the atom? Like your class is made up of girls and boys, right? Similarly, molecules are made up of different type of atoms, and these atoms, they combine chemically and they form the molecules. Now, as I said that atom is the smallest unit of any matter. Now, there are different theories given about the structure of the atom. Different scientists have worked, they have performed different experiments, and they have come out with different conclusions. So, we will study about the different atomic theories in this. Now, the very first one was given by Dalton. The scientist's name was John Dalton. He was a British scientist, and 1803 he gave the Dalton's atomic theory. Now, according to this theory, matter is made up of atoms, and atoms are indivisible and indestructible. All atoms of an element are alike, while different elements have different atoms with different mass. Now suppose we have hydrogen. Now hydrogen is made up of only hydrogen, right? Chlorine is made up of only chlorine. So it is the smallest unit which cannot be further divided into still smaller unit, and it has all the physical and chemical properties. Now John Dalton, he proposed the theory which is known as Dalton's atomic theory, and he said that the atom is a solid sphere or a bowling ball model. This was given by him. Now, according to this theory, the matter is made up of atoms. Atoms are indestructible and cannot be divided into smaller particles. That means atoms cannot be further divided. And the atoms of one element are exactly alike, but the atoms of other elements will be different. So he demonstrated that the negatively charged particles inside an atom have a mass of 1800 times less than a hydrogen atom. Now later these particles were named as electron, right? Common substances are usually electrically neutral. That means the charge, that is positive and negative, present in an atom is equal. That is why they do not have any charge. Okay, so this was proposed by Dalton, scientist. Then there is another scientist whose name was Thomson, and he gave the model Thomson's plum pudding model of atom. So he compared the structure of atom with the pudding, right? Now according to him, the negatively charged electrons are having a mass which is 1800 times less than hydrogen, right? So compared to hydrogen, the mass of electron is almost negligible. And common substances are electrically neutral. Why? Because as I said, the electrons and protons, they are equal in number. So to explain that an atom is electrically neutral, this theory was put forth by Thomson, scientist. Now as you can see in the picture, which shows plum pudding model. Now you can see there are negatively charged ball bead-like structures which are electrons and the positively charged protons, right? So he described the atom as a ball of positive charge containing a number of electrons. And according to him, the atom is electrically neutral because the positive and the negative charge are equal in number, and thus it does not show any charge. So as I said, equal positive and negative charge are distributed inside the atom, and positive charge balances negative charge. As we had studied in maths also, plus and minus, they neutralize each other and thus they do not have any charge. So the next scientist was Rutherford, and he came out with the nuclear model of atom. Now before coming out with the conclusion, he has performed an experiment which is called as alpha scattering experiment. Now let's understand this experiment. Now he took a gold foil of very thin, that is thickness of 10 raised to minus 4 mm, very thin gold foil he took, and with the help of radioactive element, he emitted the alpha particles on this gold foil. Now it was expected that the alpha particles would get reflected from the gold foil if the positively charged mass were evenly distributed inside the atom. Now as you can see, the beam of particles, when the beam of this is thrown on the gold foil, some have passed through the foil, some have changed their direction, and some have, after passing from the foil, they have changed the direction. Now most of the alpha particles went straight through the foil. For a small number of alpha particles, they got deflected from the original path and they changed the direction of their path. Now some alpha particles, they deflected through a very large angle. The deviation was too much, right? So the alpha particles that went straight through, right? They just passed through the foil. It indicates that there was no obstacle in their path. That means the space was empty, and because of that empty space, these alpha particles, they just passed into the gold foil. Now some, they got deflected through a small or a big angle. That means something has come in their path. They had some obstacle in their path. So using these observations, he formulated the theory of an atom. Now he said that atom is made up of two parts. One is the nucleus and the other one is the extranuclear part, that is around the nucleus. And he said the mass of the atom is concentrated in the nucleus, and the electrons which are lighter from the extranuclear part around the nucleus. Now this model is also known as planetary model, as it resembles our solar system. In our solar system, the sun is in the center and the planets, they rotate around the sun. So similarly, Rutherford also said that in the center the nucleus is there, and the negatively charged particles, they revolve around the nucleus, right? So this was the Rutherford's nuclear model of atom, and he performed this, he came with the conclusion of this after performing an experiment. Now, on the basis of the alpha particles experiment, he gave the Rutherford's nuclear atomic model. Now here we can very clearly see. So as you can see in this picture, this is what he postulated as Rutherford's nuclear atomic model. Now in the center you can see that orange colored round structure, that is the nucleus, in which the positive charge is present. Now almost the entire mass of the atom is concentrated in the nucleus, and the negatively charged, that is the blue colored dots which you see, they are the electrons which are revolving around the nucleus. Now the total negative charge on all the electron is equal to the total positive charge present in the nucleus, right? So as the positive and negative charges are balanced, they neutralize each other, and thus the atom does not have any charge. And the empty space between the revolving electron and the atomic nucleus, because of which the certain alpha rays, they just passed through the foil, whereas some they got distracted, right? So in short, we will just go through the Rutherford's nuclear atomic model. First point is positively charged protons at the center of the atom. Second, all the mass is at the center. Third, negatively charged electrons revolve around the nucleus. Fourth, total negative charge on electrons is equal to total positive charge in nucleus. Hence, it is electrically neutral. The positive and the negative charge are nullified with each other. An empty space between revolving electron and the atomic nucleus is present. So this is all about the Rutherford's nuclear atomic model. Then there was another scientist, Danish scientist, whose name was Niels Bohr, and he also came out with atomic model which is called as Bohr's stable orbit atomic model, which he gave in 1913. Now, according to Bohr's atomic model, he postulated that the electrons revolving around the atomic nucleus lie in the concentric circular orbits at certain distance from the nucleus. Like the planets, they revolve around the sun in their specific orbit. Similarly, the electrons, they also revolve around the nucleus, and the nucleus contains positive protons. So the negative electrons, they revolve around the nucleus in their specific orbits, and these orbits were given the name as KLMN. That is, from the nucleus, the first one will be K, the second one L, the third one M, and the fourth one N. Now the second point it explained is energy of an electron is constant while it is in a particular orbit. When it is rotating in its own orbit, its energy is constant. But if it jumps from an inner orbit to the outer orbit, then it absorbs energy. And on the contrary, when it jumps from the outer orbit into the inner orbit, it gives out the energy. That is, the energy levels of these orbits are different, right? So this was the model given by the Niels Bohr, who was. And now we will start with the structure of the atom. That is, what is the fundamental principle of atomic structure? Now, atomic structure we have to study. So we should understand that atom is formed by two constituents. First is the nucleus and the second one is the extranuclear part, right? So in the center the nucleus is there, and the electrons which revolve around the nucleus, they are called as the extranuclear part. Now there are three types of subatomic particles. First one is nucleus. Now nucleus, as I said, it is present in the center of the atom. It is positively charged because it contains two types of subatomic particles which are called as nucleons. And these nucleons are protons and neutrons. And we had also studied that protons are having a positive charge, whereas neutrons, they do not have any charge. They are chargeless. Okay. So in the center, the nucleus is present, which is having a positive charge, and two subatomic particles, which are protons and neutrons. Second one is proton. Now protons, as I said, they are denoted by small p. They are positively charged. Their symbol is P, and they have plus 1 charge, which is equal to 1.6 into 10 raised to power minus 9 coulomb. That is the total charge on one proton. Now one positive charge on nucleus as unit E, which is called as magnitude. Now it is equal to number of protons in nucleus. Now total number of protons is the atomic number of that element, and it is represented by capital Z. So capital Z is equal to atomic number, which is equal to number of protons, that is the positive charge. Mass of one proton is approximately 1 mu or 1 Dalton, and 1 Dalton is equal to 1.66 into 10 raised to minus 27 grams. So this was all about the nucleus and the protons. The third subatomic particle is the neutron. Now neutron, as I said earlier, they are electrically neutral, right? They do not have any charge. They are denoted by small n, and the number of neutrons in nucleus is denoted by capital N. Like protons is denoted by capital Z, neutrons are denoted by capital N. Now nuclei of all elements except hydrogen have neutrons. Only hydrogen does not have neutron. And mass of neutron is approximately 1 mu, that is equal to that of proton. So the mass of neutron and the proton is almost equal. Then comes the extranuclear part. Now the proton and neutron, they are present inside the nucleus, and together they are called as nucleon. Now what is present outside the nucleus, that is called as extranuclear part. Now this includes the electrons which are revolving around the nucleus, the empty space between the nucleus and electron, right? Now this we had seen in the earlier atomic models also, that some of the space in the atom is empty, some has the positive protons, and outside the nucleus the negative charge electrons, they revolve around the nucleus. So in the picture, as you can see, in the center, the nucleus is there, which contains the positive protons and the electrically neutral neutrons, and they are together called as nucleon. And outside the nucleus, you can see the orbits, the specific orbits in which the electrons, they revolve. Now this is compared to the planetary model also, because same like the solar system, the sun is present in the center and the planets, they revolve around the sun in their specific orbits. They cannot change their orbits. Similarly, here also the nucleus, they revolve around, the electrons which are having the negative charge, they revolve around the nucleus in the center. Then the last one, subatomic particle, is the electron. Now electron, as I said, they are negatively charged. They are denoted by small e with a negative charge on top of it. Each electron carries 1 unit charge, that is minus 1 e charge. Mass is 1800 times less than that of hydrogen atom. As I told earlier also, that it is almost negligible compared to the hydrogen atom. And mass of electron is negligible because it is almost 1800 times less than that of hydrogen atom. Okay. As I said, as per the solar system, the electrons, they revolve in the orbits, and these orbits are three-dimensional orbits which are called as shell. And if you remember, in the earlier picture I had shown you that if we start from the nucleus, the very first shell is K, then L, then M, and then N, right? So these are the different shells from where they revolve around the nucleus. As you can see in the picture, this is the atom of chlorine. In the center, the nucleus is there, which contains the protons and the neutrons, right, which are called as nucleons. Protons have positive charge and neutrons, they are electrically neutral. You can see the different shells K, L, M. These are the shells in which the electrons, they revolve around the nucleus. Now the number of electrons in an atom is always equal to the number of protons, right? This I had explained you, and that is the reason why the atom does not have any charge, because whatever amount of negative charge is present in the atom, the same amount of positive charge is also present in the atom, and thus they nullify each other and the atom does not have any charge. So the electrical charges are balanced and the atom is electrically neutral. So the number of electrons in the extranuclear part is equal to the number of protons present inside the nucleus, and it is denoted by Z. Okay, that is the atomic number. Now, the mass of electron is negligible, right? So the mass of atom will equal to protons and neutrons in the nucleus. Because the mass of electron is almost negligible, it is less than 1800 times than that of hydrogen atom. So the mass of the atom depends upon the protons and neutrons in the nucleus. So protons plus neutrons is equal to atomic mass number of the element, and it is denoted by element A, right? Now the atomic symbol, atomic number and mass number. Now, as you can see on the screen, A symbol, Z. Symbol is the short form or abbreviation of any element which we write. Like for oxygen it is O, hydrogen it is H, chlorine it is Cl, carbon it is C. Now, what is A and Z, right? Now, A, as I told you, A is the protons plus neutrons, that is the atomic mass number of the element, which is denoted by A. And Z, as I had told you, that it is the number of the protons. Now, in the example, you can see the carbon. The symbol of carbon is C, and it is written as 12C6. So, A is equal to 12 and Z is equal to 6. Now, 6 is Z, that means it is the atomic number or the proton number, right? So, the mass number of carbon is 12 and hence the nucleus of carbon contains 12 minus 6, that is 6 electrons. So, this is how we can find out the number of different subatomic particles which are present inside the atom. Okay. So with this, the time is almost up, and next time we will continue with the same lesson. Till then, take care, students. Stay home and stay safe. Bye. See you next time.